triangle, let's apply what we learned yesterday about geometric mean. First off, let's call B to D, I'm going to call that X. And I'm going to call D to A Y. And then C is going to be my whole hypotenuse. So what we learned yesterday, A is the geometric mean between the entire length of my hypotenuse, which is C times X. Now what we're going to do here, I don't know what these are, so I'm going to get rid of my square root. I don't like that square root. So I'm going to square both sides. So in other words, A squared equals CX. I'm going to do the same thing for B. Instead of saying square root, I'm going to say B squared equals my entire hypotenuse, which is C, times the part that's adjacent to B, which is Y. Now, I'm going to add my two equations together. So what I'm going to do is I'm going to take B squared equals CY. I'm going to write it below here. And we're going to add them up. We'll notice on the left side, I get A squared plus B squared. On the right side, I get CX plus CY. Now I can simplify the right side a little bit because notice C goes into both of them. So A squared plus B squared equals C times X plus Y. Well, if I look at my picture, what's X plus Y? Well, that's C, isn't it? So I get A squared plus B squared equals C times C. Or A squared plus B squared equals C squared. Pythagorean theorem. We just did a proof of the Pythagorean theorem. There are like 66 different proofs of the Pythagorean theorem. One of them was completed by a president of the United States. James Garfield, when he was in Congress, was having a debate with somebody, a discussion, and he realized he could use trapeziums to show it worked. Now, he had a background as a military general, so he had some of that going on, but he did publish that proof. So there's 66 published proofs, at least. There might be more. Different ways of showing the Pythagorean theorem. This is one of them. Yeah, I kind of like that one. It's one of my favorite ones. Now, what we're going to look at in this lesson is a bunch of things. We just did the proof of the Pythagorean theorem, and we're going to use the converse of that. Now, you got to have a right triangle to use Pythagorean theorem. We've done this before. We also have things called Pythagorean triples. A Pythagorean triple are three whole numbers, so no decimals, where C squared equals A squared plus B squared. So for example, on my first column here, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, that's 5 squared. And then we have multiples of 3, 4, 5, 6, 8, 10, 9, 12, 15, and so on. Anything that's a multiple of 3, 4, and 5. We also have 5, 12, and 13, 8, 15, 17. We have a bunch of them. They occur quite often. So on my first example, remember when you use Pythagorean theorem, identify what your hypotenuse is. In this case, my hypotenuse is x. So I'm going to say x squared equals 17 squared plus 7 squared. And I want the exact answer. I don't want any decimals. So 17 squared is 289. 7 squared is 49. Now if we add 289 and 49, I get 338. And then to solve for x, I'll take the square root of that. I want the exact answer, so let's simplify that. Well, if I divide by 2, 338 divided by 2 is 169. And lo and behold, 169 is 13. So it's 13 radical 2. That's x. Now my next one, I'm going to use a Pythagorean triple. So look at your chart. Which one has a hypotenuse of 50 and a leg of 14? So 50, oh, look at that one. Fourth column over. One side is 14, so what's x? X is 48. That works out pretty nice when you do that. Now, on our next example, we got this design question here. And the question says, a summer camp is building a new zip line. The course, or the designer of the course wants the last zip line to start at a platform 450 meters above the ground and end 775 meters away from the base of the platform. How long must the zip line be to meet the designer's specifications? So we'll draw this out. So it starts up here, and we know he's starting 450 meters in the air. He moves horizontally 775 meters. And then here's our zip line. And we want to know what the length of that is. Well, we'll call that C. So C squared equals A squared plus B squared. It's just like we did the other ones. So C squared is 450 squared plus 775 squared. Well, when you do that, just using our calculator, 450 squared is 202,500. 775 squared is 600,665. So C squared is 803,125. I take the square root of both sides, and on this one, it's a real life problem, so let's write it as a decimal. We're not going to write it as a, I'm not going to make a factor to for this one. So if I take the square root of 803,125, I get about 896. I get a decimal, but we'll round it. So about 896 meters would be the length of our guy wire. Now we can look at the converse of the Pythagorean theorem. And the converse of the Pythagorean theorem says this. Hey, look, if I've got three sides where C squared equals A squared plus B squared, 68.3, A squared plus B squared is 68.3. It has to be a right triangle. What happens if I make C squared smaller? Notice 42.1 is less than 70.4. Notice all three angles are acute. And then if I make it bigger than 90, notice C squared is bigger. As long as you write C squared first, it's going to make sense. C squared is bigger, obtuse, C squared equal, right, C squared smaller, acute. And once again, though, you got to make sure it's a triangle first, though. Don't forget about that part. And so that's what your three converse theorems say. They're saying, hey, if c squared equals a squared plus b squared, if I don't know what kind of triangle it is, well, that would make it a right triangle. Now, if c squared is less than a squared plus b squared, it's going to be acute. And if c squared is greater than a squared plus b squared, it's going to be obtuse. When I say c squared, I'm saying the longest side squared, because we don't know if it's what kind of triangle it is until we do it.